Hello, this is lesson 22, your video notes, and you're going to title this Equivalent Rational Expressions. And the first thing we're going to do is we are going to talk about what is a rational expression. And it is an expression that is the ratio of two polynomials. It's also a fraction with polynomials, and it's also just polynomial division, which is what we've been dealing with long division and with factoring. We've been dividing polynomials, and now we have a name for it. It is called a rational expression. But in textbooks, you're also going to see that sometimes it's just called P over Q. And what they mean by that is they mean P and Q are polynomials. And now that we're talking about rational expressions, we're also going to talk about something called when the rational expression is undefined. And so this P over Q is a rational expression because they are both polynomials, but Q cannot equal to 0. And we're going to have plenty of conversations about why Q cannot equal to 0 in class and how we solve for that, et cetera, et cetera. But today we're just going to worry about simplifying rational expressions. So one of the most powerful ways that you can simplify rational expressions is using the property of 1. In any time, a rational number, an example of a rational number is a fraction, like 1/3, 2/5, 4/7. It is a rational number, it's just a fraction. A rational expression is a fraction with polynomials in it. So we're going to have to rewrite fractions and polynomial fractions into equivalent forms, and we're going to do that using the property of 1. So if we have 1/3 and we want to rewrite 1/3 with something over 6, we know we'd have to multiply by 2 over 2 to get 2/6, because these expressions are equal because 2 over 2 is 1. And if you multiply anything by 1, the property of 1, you do not change the identity of the original number. So if we had 1/3 and say we multiplied by 3 over 3, we would get 3/9. 1/3 and 3/9 are equivalent expressions. We've just multiplied it by 1, so it looks different. But we can keep going, and we can write 1/3 over 4 over 4, and we can get 4/12. And because 4 over 4 is 1. And we can even rewrite it as 1/3 over n. So we multiply 1/3 by any number over any number. As long as those two equal to 1, we will again get an equivalent fraction. That's not right. N over 3n. Okay, so the point of this is we're not just going to be multiplying by numbers n over n. We're not going to be multiplying by 2 over 2, 3 over 3. We're going to be multiplying by like 2x over 2x and x squared over x squared and x minus 1 over x minus 1. We're going to take any factor, anything we can put in parentheses. If we put it in the numerator and denominator and it equals to 1, then we can multiply it by another expression to write equivalent rational expressions. So that's what we're going to be doing for a while. So let's try some examples here. Okay. One of the ways to rewrite equivalent expressions with rational expressions is to take out the greatest common factor. And sometimes if you take out a factor in the numerator and the denominator, you are going to be able to cancel it out using the property of 1. So we have over here 4x. There's no greatest common factor in the numerator, but I'm going to factor out a 4. That means I'm going to put 4 times x. So I'm essentially separating them by factors, 4 and x. I'm going to do the same thing here. It's kind of already done for you, 4 times x minus 1. I have x minus 1. And now I can simplify 4 over 4 because it's equal to 1. So I have factored out 4 over 4, which is equal to 1. And I'm left with an equivalent expression of x minus 1. That's fine. So let's try it with a little bit different numbers. Say my denominator is not already factored for me. Now I'm going to take a look and be like, okay, so my largest common factor is 3 in the denominator. Now, it would be really helpful if there was a factor of 3 in the numerator that I could cancel and simplify to 1. Oh, because I have 12, 3 is a factor of 12. So now I have 3 over 3, which simplifies to 1, and I can rewrite my equivalent expression as 4 over x minus 3. That's good. Let's do the same thing, except let's throw some negatives in there and take it nice and slow so you can take notes and make sure you annotate. If negative ones are where you get stuck or you have a lot of your errors come up, this is where you can make a little caution sign and come into office hours to ask about negative factors. So I'm going to take a look at negative 3 over negative x minus 4. I'm going to take a look at the denominator first. The largest common factor in the denominator is probably negative 1. And by probably, I mean it's negative 1. So if I take a negative 1 out of negative x, and if I had to reverse distribute, and I took a negative 1 out of negative x, I would be left with positive x. Same thing. If I took a negative 1 out of negative 4, I'm left with a positive 4. With negative 3, if I take a negative 1 out of negative 3, I'm left with a positive 3. These are factors. Okay, because negative 1 is a factor of negative 3, then I can simplify negative 1 over negative 1, and I'm left with an equivalent expression of 3 over x plus 4. Okay, let's try one more. Take a look closely at this problem. You have negative x over 1 minus x, not x minus 1. 1 minus x does not equal x minus 1. You cannot just switch the two terms around, especially when there's a negative. It messes things up. Okay, but what we can do is we can factor out a negative 1 in the denominator. If you factor out a negative 1 in the denominator, it can help you switch the terms. I'll show you how. So I want negative 1 times something. I'm going to do my scratch work over here. So if I take negative 1 out of my denominator, a negative 1 out of positive 1, I'm left with a negative 1. And a negative 1 out of a negative x, I'm left with a positive x. Let's check. If I had to distribute this, I would get my values back. Okay, good. Now that there's a positive sign in between, I can carry the signs, as in this plus goes with this x and this negative goes with this 1. And now I can switch my terms around, x minus 1. So these two expressions up here are not equivalent, but they're off by a factor of 1. So now I'm going to plug this part back into here, x minus 1. And if I take a negative 1 out of the numerator, I'm left with x in the numerator. So negative 1 over negative 1 is, again, a factor of 1. And now we're just left with x over x minus 1. The last thing I'm going to talk about is a common misconception that I see a lot, and we're still wondering, like, is this okay? And what I'm about to tell you is what I'm about to do is not okay. So let's go back to the first expression, 4x over 4x minus 1. Don't do this. Stop. No. Okay? I'm about to do something. So if I have 4x over 4 and x minus 1, I see a lot of people do this. You just, oh, there's a 4, there's a 4, there's an x, and I'm left with, you either put 0 over negative 1 or you put negative 1 over negative 1, and you're like, there, I'm done. And I just want to say, no, you can't do that. The 4, you can cancel out factors. If you notice over here, 4 is a factor of 4x. 4 is a factor of the denominator, so that you can separate them by factors, and then you can cancel. But 4, you cannot cancel a factor out of here and half of a factor in here, because a factor is x minus 1, not just x. So that is a very common misconception. If you find yourself doing that, make sure you put a little caution sign when you are practicing so that you can go back and annotate and reflect if you have been improving on this. Have you been catching yourself canceling out not factors? Anyway, write any questions you have underneath that was unclear in your notes, and then we are going to see you tomorrow. Bye.